Good morning, everybody. I'm Ben Greisler. This is John Seward. I want to thank John for coming out and helping me with this. I really appreciate it. And I really want to thank everybody here because it's Friday morning. It's the last day. I'm sure you all had a good time last night. And at least I hope you had a good time last night in whatever format that means for you. And, we're talking about something here that, quite frankly, is not very exciting, but it is something that impacts all of us. Let me ask you a question. Has anybody here sat in any of my previous DNS presentation? Cool.
That's why I came to MacAdmin for this presentation.
Thank you. I appreciate it. Actually, what time did you finish up last night? I just heard that you all went pretty late. I got the impression maybe it was a little bit longer, but thank you for coming out. So the reason why I'm doing this presentation is I've done multiple presentations on kind of the basics of DNS, the nuts and bolts of DNS. And maybe one day I'll go back to it because I haven't done it in a while. But I keep thinking that maybe I've overdone it. But I still think that DNS is such an important topic that we do need to talk about it, and what would be an important piece of DNS to talk about now. And I realized after watching a demo on something, how many DNS lookups get triggered when we use various cloud services. It was shocking. It was probably 10x what I thought it was, going to like a website that any one of us would have gone to. And that just triggered in my mind, like, holy cow, what is it we can do to make sure that any DNS services that we have some access to control, what can we do to make it best for our users? So let me ask a couple of questions. Well, actually, before I do that, hold on. While I'm talking, you can go to the QR code, and hopefully it's going to work. This will pull up a document off of a web server somewhere that has these links on it. And pull it down. There's going to be some kind of do-it-yourself during the session. So it'd be great to open up these links in some tabs, get them ready to go. And does anybody here have Brew installed on their computer? If you've got Brew, there's two packages that you can install. One is this DNS Top, and the other one is DNS Pyre. And they take just moments to load up, and then you can do some stuff while we're doing our demos and kind of see it for yourself. So I would recommend that.
Which two DNS Top is the other one?
I'm sorry?
DNS Top and DNS what?
Pyre. It's where I've got Brew. I'm pointing something you're not seeing. Yeah, so this one here and that one up above the QR code. I will say, so like for DNS Top, it's literally just Brew space and small space DNS Top. But the other one, DNS Pyre, you need to go to the link for the installation. You have to do a tap to get to it. You just can't install directly DNS Pyre. So you need to like do the tap, and then you can install it. But it takes moments, very quick. So the whole concept here is, what can we do to make things better? How many people here have the responsibility for the DNS of their organization? More than half. How many people here are still running internal DNS servers for your environment? So interesting. I think there were more hands there than the previous question. Yeah, you could have it and be responsible. Okay, so this is good because we're going to be talking about both sort of that internal and the external. And honestly, when I was thinking about this, I was really thinking more about the external part, because that's the part that typically we don't have as much control over. But we're going to see exactly where we can have control, or maybe we don't have control and we just have to realize that. general flow for the session. We're just going to do a quick DNS review. If you've got any questions, stop me. And we're going to talk about performance concerns. You know, what are the things that we should be concerned about? How do we measure them? And then ultimately, what can we do to make things better, different, whatever it is. Also very important, because I haven't seen any presenter mention this. Does anybody know what this is? This is the bottom of the catch box. How many people here have read the bottom of the catch box? According to the catch box, this is a dangerous item. So I don't want, it's Friday, I don't want any injuries with the catch box. I was just amused at our first presentation. I'm like, oh, there's instructions on the bottom of this thing. Okay, let's start talking about DNS. This graph was supplied to me, or at least concept for it, by my daughter, who happens to be a comp sci minor. And when I was bemoaning my task of doing slides, she goes, listen, you've always told me, do pictures, don't do words. Basically, she repeated the whole Steve Jobs thing to me that I had told to her. And she goes, just make a graph showing DNS good, DNS bad, and this is what it is. So we're going to talk about the optimization. The orange is where we really don't have optimized DNS. That's bad. It's downward trend. We're going to get it where it's an upward trend. I had to give my daughter credit somewhere there. All right. So this is our users having a bad DNS experience. It's also AI, and don't look too closely at the picture because it's absolutely humorless, well, kind of, humorful for kind of things that are hidden in there because it's AI. I actually found some other stock pictures. They were just terrible. All right, getting into it. What is DNS? Class. What is DNS? Domain name server. What does domain name server mean? All right, you all run DNS servers. Do we see the issue here? Words to numbers. Thank you. You have actually sat in you have proven that you have sat in. But this is basically what it is. While there will be descriptions of DNS as the address book for the internet or address book for a network, something along those lines, when it comes down to it, it's translating something into something else. Usually, when we think about it, it's the words. It's the say URL into an IP address. But it can be other things. It could be one fully qualified domain into another fully qualified domain. It may be just simply providing information about something. It may be pointing to a resource based on what request it got. So this is what we do. And there's lots of different types of records that are provided. Our knowledge of these different types of records become important later in the session when we realize that we may have to treat some types of records differently than others when it comes to optimizations. Questions so far? Okay. So with DNS, great, it's out there. Probably this room is pretty well understanding of the actual mechanics of it, that we have DNS servers and requests are made. How do the clients or the users of the DNS know what DNS servers to use? Well, we can hard code it, which may be useful in some cases, but if something changes, chances are we're using DHCP on end client usage. Because once again, I'm thinking cloud, I'm thinking somebody with their laptop, their phone, an Apple Watch, whatever it is. Not so much, I'm just kind of setting the expectations. I'm not necessarily thinking about a server in a rack somewhere, but somebody out in the world, because they're the ones who are really going to be using the cloud services. So chances are they're going to be having that DNS server provided to them via DHCP. We connect to the wireless here. Our device asks for, broadcasts, hey, I need an IP address. There's that exchange, the whole DORA thing, and then eventually we get the IP address, subnet, the gateway, the DNS server or servers. It all comes down. So somebody's made that decision for us. But if you're in control, let me ask this question. How many people here are responsible for what network resources their clients use? And let me explain. If you have a fleet of users out in the field, do you manage what they're able to access? Yeah, some of you. Some don't. Some are just, go out there and we only control what's inside our walls. Or if you need to connect to M365 or Google Suite or whatever it is, that's just what it is. But we're going to see we may actually have some more control than we expect. All right. So the mechanism of it, and I will have a quiz after this. So pay attention to the screen. All right, so we have a client who wants to go to YouTube. They make the request, goes out to the DNS server that was provided to it how? It was either via DHCP or it was hard-coded, one way or the other. So it reaches out to the DNS server. DNS server may have an actual answer for it. What would be a situation where the DNS server has an answer right away for the device? In this situation, most likely caching. But it could be authoritative, particularly if it's in your own network. So if it doesn't, though, it may need to reach out. In this case, it has its answer. We'll talk about the second piece a few slides down. It reaches out to the server. It has the answer that it needs, and it gets to watch whatever it is they want to watch. So that's the general mechanism. Request, gets an answer, does what it needs to do with the answer. All right, let's talk about some concepts of DNS real quickly because we'll need to understand these. You guys are pretty up on this, so we can go through this quickly. Forward DNS. What kind of record is associated with forward DNS? A record. Or possibly a quadruple A record. Where would you find a quadruple A record? IPv6, right. Okay, reverse DNS, same concept, just in the other direction. Top-level domain, something we need to understand. Top-level domain is something like .com, .net, .edu, .gov, .co.uk, not your UK, different UK, of course, Johnson, Kentucky. And a domain is the combination of the top-level domain and the domain itself. We have our host name, which is usually a resource within that domain, and fully qualified domain name. And extra credit for anybody who's been to my previous presentations, because yes, I lifted these slides directly from it. What's coming next? Is this, in fact, a fully qualified domain name? No. Why? Trailing dot. Thank you. Excellent. Do we ever actually use that trailing dot in like regular use? No. But it's technically part of it. All right. A zone. A zone is simply an area that may define all or part of the information related to a domain. If you have your own little world, you've got an office of 10 people, but you have got your own DNS going, your zone may be just in that office, physically and logically. But if you're IBM, if you're Google, if you're Microsoft, you're going to have resources distributed across the globe, and you may have it broken out into some logical areas of control based on administration needs, geographic location needs, possibly geopolitical needs. So you can split things up into different zones. The authoritative zone is where the official information for a particular domain is kept. And then we have the start of authority, which is a record that describes that information. This is an example of a file from Bind 9, I think, something like that, that actually describes the start of authority. It gives us all the information, gives us the times to live, gives us a bunch of information in there that together creates that start of authority for this case, happycamp.org. So time to live, that's kind of a macabre description, but what does it mean? When we talk about a TTL, what are we talking about?
How long you keep the record until you have to refresh it?
Yeah, how long do you keep the record until you refresh it? Why is that an important concept? Reduce traffic? Information changes. I'll change your answer to information changes because it could be a domain thing, could be a subdomain thing, could be whatever. And if you have a TTL defined, because you as the controller of the domain defines what the time to live will be, that's under your control. If you set it real long because I want this to stick, that's fantastic right up until the time that you need to make a change for the record, and now it's hanging out in somebody's servers for 3 days. So you might flip to the other side and go, you know what? I'm going to change the TTL to 30 seconds. Well, now you've just made a lot of people unhappy watching traffic whiz back and forth. And there's a balance in there. We're going to talk more about it. All right. Root servers. Obviously, no one server could have all the information about everything in the internet. Matter of fact, if you've got a pretty big environment of your own, you may and should have multiple DNS servers. And you can have redundancies, and then you can have different servers that are handling different pieces of the network. Same thing with the overall DNS service out in the world. So the root servers, there's 13 of them. Do you actually think there are just 13 boxes scattered around the world answering all the information about where top-level domains are? Yes, they're huge, and they put out a lot of heat, but you're never going to get cold while you're there. No. The root servers are literally scattered across the world. There are hundreds of them, but they are broken up into logical groups. So Zone 1, or A, might actually be comprised of dozens of physical servers or instances or VMs around the world. Why do you do that? Redundancy, load balancing, availability. It's hardware. Eventually, it's going to break. You need to have that resilience. All right. Interesting tool came across. It's called DNS Root Explorer. It's available for free off the Apple App Store. You can go grab it if you want. Take a look, because what it does, when you just go in there, click the test IPv4 or IPv6, it will reach out to whatever DNS server your device that you're running this on has been told to use, and then it will do the checks, and it will go and figure out which root servers are going to be used in your situation at that moment in time. It's pretty wild. And in the example here, most of these results are concentrated on the eastern portion of the US. There's one San Francisco in there, but for the most part, it shows that these types of requests will be tried to be answered as close as possible. So it's interesting. So I recommend downloading and play around. It gives you a little bit of insight to what's actually happening. All right, another concept, recursion and iteration. And this is something that I have to admit, when I first started doing all my DNS research stuff, I wasn't getting it. And then I found this. This is from Microsoft's training, and it made things completely clear. And we need to understand the concepts of recursion and iteration, because that's going to kind of color some of the choices that we make if we're going to try to optimize our DNS. So when the client, more specifically the resolver on the client, because there's going to be some mechanism on your client that is in charge of doing the DNS lookups, it's going to go, hey, DNS server, I've got a question. And once again, Who is it asking? What DNS server is it asking that of? Yeah, whichever one it was told to ask. So it's going to reach out, and the name server is going to either have the answer or it isn't. Why might it have the answer? It's gone there before, and the information has been cached. Or maybe that server contains the information for that domain. Maybe that's its entire job. But if it doesn't have the answer, it's got to reach out and find the answer because the resolver on the client has told it, I need a recursive answer here. Either you give me an answer or you tell me you don't have it. Basically fail, but fail in a way that I know that it's a fail. There's actually NX domain that say, don't have the answer. But the name server will reach out to where? The root server. The root server knows absolutely nothing about, in this example, www.whitehouse.gov. But what it does know is where the servers are that contain the information for .gov. So now the name server can reach out to the .gov servers and go, hey, I need to know about whitehouse.gov. They're like, I don't know about whitehouse.gov, but I can tell you where that domain is hosted, so it now goes checks with that. Now, when it's talking to that DNS server, it says, hey, I need to know www.whitehouse.gov, and it goes, yep, I got you. Gives them the information. The name server can now complete that recursive query and shoot it to the resolver on the client that made the initial request. Now, this is where we start talking about performance, because we've kind of talked a lot about generalities at this point. Can you see where if you are trying to create a high-performance DNS answer, if you have to keep going through this process, and it's not just one lookup. If you click on, you go to office.com, that is what it is, it's office.com, right? And you click on that, how many DNS requests do you think that actually triggers? Just one? Well, I don't actually have the answer for you. We'll talk about how we might be able to figure that out, but it's a whole lot more than one. Or if you go to a website that maybe you're providing that has a lot of different elements in it, each one of those elements probably will turn into a lookup. So if the answers aren't out there, all of this process will get just over and over and over and over again. I did watch, and it's in the resources, there was just a fantastic discussion about this. And they were using like the CNN front page, and it turned into something like 400 lookups. And I mean, granted, that's not cloud service in the way that we're kind of talking about it here, but they made the point that a couple of milliseconds here and there could turn from a reasonable user experience to all sorts of delays while it's still filling out everything that's on the page. So you want to make sure that you're going to give it the best shot that it has. So we're starting to build on the concepts here. All right, different ways of providing DNS real quickly. We have split DNS, where we'll have a DNS server that handles stuff inside of our network that's under our control, and then we have a DNS server that handles requests on the outside. Because while we might have, say, a mail server that resides inside our network, it needs to be able to be gotten to both inside and outside, and it's usually a bad idea unless it's sitting out on a DMZ, which is certainly possible, where we're going to try to put the traffic, like our internal mail traffic, out to the internet and have it come back in again to get the request or whatever. We're going to try to keep things local for better performance. At the same time, your users in the outside world still need to get to your internal mail server, so you need to provide the DNS and the NAT and however you're doing it. If you're cheap and you just want to use one DNS server, which you're not going to do, you can use something called views. Different DNS servers have different names for this, but essentially it's one logical DNS server that looks at where the request is coming from and gives the appropriate answer based on where the request is coming from. All right, so we were talking about caching, and this is my terrible attempt at graphics, an example of what is probably a fairly common situation. We have our client. This is all stuff that you can get in Keynote, which is why it's not gorgeous, because I'm not a graphic artist. It makes the request to the DNS server that it was told to talk to. That DNS server, in the other examples we had, now reached out to the root server and down, down, down. The reality is, in a lot of situations, we will have a forwarding server or have our internal server set as a forwarding server. So if I don't know the answer to it, I will go refer to another server that has been defined. And if you forward to a common outside DNS server, there's actually a really good chance that that server may have the answers, because if it's serving a large swath of people and people are trying to get to M365 or Google Suite or Amazon or whatever it is, there's a really good chance that other people are trying to look for it also, and it could speed up the response time. So that's what potentially could happen. If that other external DNS server doesn't have the answer, it's going to do what? Yeah, it's going to go to the top level and blah, 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 go down the whole thing, do the iterative search. But point being is, we should be aware, if we're hosting our own internal servers, does it make sense maybe to forward to another external server? And that's just an answer that you'll have to come up on your own. Hopefully, at the end of this, you'll have a little bit more to think about to help you with that decision. All right, now we're getting into sort of the nitty-gritty. Cloud services make a bazillion DNS requests, or a lot of times they can do that. Issue, problem, what do you think? Maybe, maybe not. We don't know because we haven't tested it yet. And this is what we want to do as system administrators or people responsible for this, or tell somebody else, go do this, because this is probably a good idea. I'm going to go to lunch. And you start running into some questions at that point. What is it that I'm even testing against? Now, in my research, I know this stuff exists. I've seen it before. You can go and look at the data provided by your various resources. This is what the Google information on what servers, what URLs, what resources they provide. And you can see it is not a small number. And this is just the first part of the page that all these are listed on. So I'm like, all right, let's take a look at Microsoft. This was literally just one section of one page of all of the pieces. Now, if you really, really, really wanted to provide fast DNS, you'd set up a caching server or your own server with all of this information on it, but no one's going to do that. But I'm really just doing this to illustrate that, one, you can figure out where all the stuff is going, and you can test against it. But it's a lot. It's a lot. But the information can be gotten. All right, so what defines DNS performance? It's actually kind of easier than you'd think. First off, do we even get an answer? You expect that if you ask the question, you're going to get an answer, right? Well, there's no guarantee of that, but usually it works. The second one is, did we get the answer that we expected? Is it correct? Because maybe it's not the right answer. Why? Can you think of a reason why you may not get the right answer? You get an answer, but not the right answer. Right. It could be a stale entry. That could be your fault because you set a super long TTL. Or it's somebody else's server that you're trying to pull the information from in a lot of cases. Their server should be respecting your TTL. Is there a guarantee that it will respect your TTL? Nah. That's not very nice, but it happens. Now also, with the example of the root servers, where one of the root servers may physically be dozens and dozens of real servers, that same thing can happen if you're a commercial DNS provider. I'm not saying you, but say you hire Cloudflare or somebody else to do that. There isn't 100% certainty that all of their instances that comprise their DNS server are all going to agree all at the same time. Maybe 1 out of 20 nodes, for some reason, didn't synchronize, didn't get the latest information. And depending on luck of the draw, if that one node answered the question with the wrong information, you'd be like, what's going on here? But then you do the test again, and it pops up okay. So you have to understand how these things are physically put together. All right, performance. We tend to think performance fast, but the reality is, do we get an answer? Do we get the right answer? Then how fast do we get it? How do we measure speed when it comes to DNS? Well, in milliseconds, but what's the word that we typically talk about? Response time, latency. Yeah. So typically we'll see latency, particularly in the tools that are reporting it. Now, the other thing is, all right, I tested 3 times in a row, got an answer, tested a 4th time, didn't get an answer. What the heck's going on? Maybe that DNS server is just slammed and it missed me. So maybe that's not a reliable DNS service to be using. And then do we always get that right answer? Do we get it fast? Is it always correct? Delivered to us quickly, reliably? This is what all goes into really defining a good performing DNS service. All right. I asked the question already about who's doing internal, external. Let me just ask the question, why are you still hosting internal DNS? On-site servers, so you've got local resources that need to be told, everybody needs to be told where they're at. Okay. Okay, so VPN resolution, mostly site-to-site, you said, in your case? Okay. Any other?
System keeps working when you drop your internet connection. You can still do internal services and such.
Oh, interesting. So if for some reason you lose contact with the outside world, at least everything keeps working on the inside world. Okay. But does it default to that? Meaning is...
For local printers and other resources in the network.
Right, so, but it's not waiting for the outside. It's just always working, but it allows it to continue to work if in case. Yeah, okay. This is something that kept popping up. And give me a couple more minutes. Trust me, things are going to get more interesting soon. How many people here use a DNS filtering system for security? Okay. I actually expected more hands, about maybe a quarter of you, 20% or so. Why do you use that system? I mean, it's in the name, right? You're hoping that it's going to filter out things that you don't want people to go to and provide.
Bypassing by preventing port 53 to anywhere other than my filters.
Okay. So if you're using a DNS security filter, how much control do you think you have over that system? Not much. Matter of fact, just about none. So this is the one thing that kept popping up as I was putting this together. I'm like, you know what? If you're using a DNS security filter, probably any of the techniques that we're talking about here go out the window. But it's a advantage versus disadvantage kind of thing. So if you're thinking about security, and if you end up with a little bit laggy response time, it may be absolutely worth it because you know that your security is where you want it to be. But just be aware of that. But you can still benchmark, and we'll talk about that very quickly. So actually, if it gets really, really bad, with some of the things that we're going to see here, you may be able to go back to the company that provides the DNS filtering and say, hey, fix your stuff, or this is what we're seeing. And, you know, The good thing about IT folks is even if they completely disagree with you, typically if you show them data, they'll go, oh, okay. You know, I may totally despise you, but yeah, you're right. So, all right. So let's talk about the actual optimization part. Understand that you may not be able to do anything. You need to understand what the layout of your system is, how it interacts with the outside world, and where all the requests are going, where they're coming, what's holding them, what's managing them, all that type of stuff. You're going to want to understand this. You'll want to map it out. You'll want to have a picture of what's going on. Once you understand that, now we can start doing our benchmarks. We're going to give you some tools to do that. And if you have the ability to make those changes, you go and you do it, and then you repeat. You run the benchmarks again. Did I achieve what I wanted to achieve? Or, wow, I just spent an entire afternoon making all of these tweaks, and it made about a millisecond of a difference every 10 requests. So that probably tells you you did a pretty good job the first time around. Okay. Draw yourself a grid in whatever format you need it to be, and just start plopping in your information. All right, this is where it gets a little more interesting. How many people had a chance to pull down some of those tools maybe installed via Brew? Cool, one of you. Did you open up maybe some Windows with the other tools in it, the web stuff? It's worth doing if you have a chance because you can kind of do this along. So one of the first things that we're going to want to know if we're going to benchmark our performance is what's actually being asked for. Good way of doing it is using something like Wireshark. Who here is familiar with Wireshark and use it? Excellent, good. Every time that I use it, I have to relearn it, but every time that I also use it, I'm like, oh, this is really cool. So how do we get the information to put into Wireshark? Well, we can use Wireshark itself to gather it, or we can go into our systems currently. This is actually one of my customers, Meraki console. You can go right in there, put some definitions in there, and pull down a capture, grab the file, pop it into Wireshark, and see it. Another tool, which is at DNS top, it will list for you what all's going on. So, John, do we want to do a demo of this now? What's the mirror thing? Oh. Yeah. So I've been leaving Wireshark running, just capturing whatever traffic's coming across my computer at the moment, and you can see what all's happening. And it's pretty interesting. A lot of this stuff you go, okay, makes sense, and every once in a while I get something like, what the heck is that? But John is SSH'd into servers that he controls, and he's got a couple of tools running on there that we can see what traffic is flowing. And this helps us understand what people are looking for.
It appears to have dropped the connection
Oh,
during the presentation. But that's all right. We can just log in again unless the network has dropped, and then we can't log in again.
really? We have upset the demo guy. This was all working half hour.
34 minutes ago, we were using a hotspot to prevent
Right,
that.
because I've got it physically tethered to my phone.
tethered Wi-Fi. Oh, that seems to be working. I tried to avoid the DNS and only use an IP. There we go. All right, so this is a server somewhere else at a colo that's actually running a handful of things, as well as a couple of bind iterations on a public-facing net. And so you can get an idea of how DNS top will show various things on a little bit larger setup here. It takes it a minute to start calculating a few things and finding some stuff. If we wanted to try a simple experiment, we could have everybody in here that's got a device try and resolve the name, ping the host or whatever, mail.sword.net, SOWARD.net, and see if we can raise this one to a higher level than some of the others that are on here. Now, it may not work because, especially if you're on the hotel wireless, I've been using that. My phone's checking my email on that, and so it may already be cached locally, and thus nothing will actually change here. But it looks like it did work. If a few people have done it, it's already moved up to second place. I doubt it will get past first place there because there's a lot of internal traffic on that domain that'll be difficult to replicate remotely with a small number of people. But you get the idea that you can use a tool like this, but sometimes running the tool in the right place is important. Sometimes running it on your laptop or on a device in your office is ideal. Other times you may need to run it closer to the source of what you're looking at. Oh, this is Reagan's domain. I knew I had anything on that still. The other thing is there's a kind of a command line Curse's version of Wireshark that you could also run on a remote server called T-Shark. And while you don't have all the cool pull downs and everything, the syntax for your filters is the same. You can just run it from the command line, and thus you could capture all of the information, in this case, from all of the interfaces on this machine. It has about 3, and you can sit here and watch all this go by, or you could archive it to a file and then bring it over and inspect it somewhere else. But if you just needed to do a quick test on something, whether it's remoting in even to someone's desktop via SSH or something without disturbing what they're doing, ask them to just keep working as normal, and I'm going to watch what's going on and see what they're resolving and what all is happening with it. That's just another quick tool that you could use that should be semi-familiar to you if you've used the graphical Wireshark on your Mac.
Now, also, only because I ran into this once, be careful of what you see and whose devices you're running this stuff on. Every once in a while, I've seen some things that were like, oh, that's interesting that they've got a tab open somewhere to that. So just be aware of that. You're going to see everything.
It's also maybe worth pointing out, I don't know if they all scroll by, but sometimes you see these whole bunch of queries like here with all of these mixed case queries. I mean, that's almost certainly someone trying to probe your site for various things because, the domain name system by design is not case sensitive. So if you see something that's purposely wacky like that, they're using it internally to log something and tracking what their results are. So, you might see a bunch of those, you might consider just blocking the IP that made those requests.
Cool. Wow, worked. Okay, so the next thing, now we know what we're looking for and what's being requested. The next point, the next thing that we're going to want to try to figure out is just how fast is the DNS resolving these things. So I tried to pick tools that were simple to use, didn't require any major depth of knowledge of command line, although the command line tools that we're showing you are really easy because you could run them, like if you do a remote session, you might be able to actually run that in the background of one of your client machines. They don't even know what's going on, and you can see what's happening for them. So now we have this DNSSpeedTest.online tool, and feel free to open it up and poke around. And what it will do is reach out to DNS servers geographically close to you, or maybe logically, depending on what kind of connection you have, and give you results. And this can be interesting because you'll see that some perform much better than others. And if you've got users who are complaining about slow response times, maybe this will help you tune in and go, you know what? Don't use Comcast. Let's put you on Cloudflare, or let's put you on Google, or we have another service that we've tested and is fast. or more reliable, or whatever it needs to be for you. And it has a predefined set of common domains it's going to test against, but you can go in and edit it and put in your information, because we've figured out from that prior piece where our clients are trying to get to. So now I can take that information and plop it into a tool like this and figure out which of the local DNS servers will do the best job for me. Another tool, that DNSPire, this is, it's command line. You can install it either directly, or I used Brew because I'm lazy and it was easy and it required about that much thinking to do. And what you can do with it is say, give me the response for this particular domain from this particular server. So in a sense, it's like that previous tool through the web, but via command line, and I can narrow it down to smaller points. I could do basically the same thing with the other tool, but this gives me a little bit more graphic response or information about the response. We can see how many tests it made and how long it took. And if you do this enough time, you'll start seeing patterns form. And you can test different DNS servers and go, all right, this one might have a better mean, but this one has a better average, whatever. And you figure out what it makes sense for you to do. Okay. Questions so far? Okay. I know what it is. Nobody wants to ask a question because now they know just how dangerous this thing is. All right. So in my quest, so my degree, I fell into the IT world. I was never intending to be an IT person when I made my career choices, but I ended up here. What I was a mechanical engineering major, and one of the things that I learned about engineering is a good engineer is lazy. And when you first hear that, you're like, well, that's kind of discouraging and that's kind of bad. And it was explained, no. The easier you can make things on you or whatever it is you're doing, the better off you are. Because it's just going to reduce the required bandwidth in your brain. Just make it easy. If you can figure out a way of doing something efficiently, cleanly, neatly, do it. And I found this tool for testing. There's a couple of websites. This is just one of the, I think, 3 that offer the same tool. You go there and just click there's a Test My DNS button. And it does a whole bunch of examinations of what's going on based on where you're at and what DNS server your device is using. So I was at home when I ran these tests. The first one, which you see in the upper right-hand corner of the window, it gave it a letter grade of a C. That was my local ISP's DNS server. Now, the way that it was set up was, in all honesty, I really wasn't even paying attention, but my computer via DHCP was just told to reference the router, because it was just like a home Verizon Fios router, whatever I happen to have there. And that forwards the requests out to their DNS servers. Why I've left it this way for so many years, I've got no clue, but apparently that's what I did. And it came back with a C. Yes, I got answers. Some were good, some not so much. So I'm like, okay. So I hard-coded in my computer to use I believe Cloudflare is 1.1.1, and boom, hit the button, much better results. One simple change. And this tool allowed me to be lazy and go A better than C, which I've told my kids over and over and over again, and I have never shared with them my grades. So my kids are much better students than me. I don't know where they get it, but I am so happy for that.
Quick question. You said on your computer, would you change it on your
So yes, now what I'm going to do, because I learned, now I'm going to hard code in my router when it's giving out the DHCP. I will probably give it the Cloudflare because it is a better performing DNS server, and that way I don't need to hard code it on my computer because, example, a couple days ago, the Wi-Fi here was stellar, right? It was just fantastic. So I go up to my room, I connect to the guest network, and just nothing's coming across. Looks like everything's live, nothing's coming across. Long story short, I realized I had hard-coded a DNS server that didn't actually exist. So, I mean, if I had Cloudflare in it, it would have worked fine, but I didn't. I was testing against something else, and I just forgot to remove it. So if you're in a lab and doing your testing, that's fine to do that stuff. But if you're, this is my computer. You know, everything on here from business stuff to making sure my wife isn't mad at me because I didn't respond to a text that she sent me, you know, it's got to happen, so it's got to work. All right. This is a tool that John told me about, which was really pretty fascinating because it allows you to track the propagation across the system of whatever it is that you're testing against. In this situation, I put in my company domain, catamac.com, clicked the button, all came up with green checks, which means that all of the DNS servers that it referred to all had the right answers. But what happens if you're doing a DNS change? Change of a mail server, change of whatever it is. How long does it take before all that information gets sent out across the world? Because it could be across the world. A lot of times we don't know. We just, I mean, I'm sure we've all done this. You know, you make a change of a DNS server, you change the MX records, and you know that even though you've sent out 10 emails saying, hey, starting Friday night until, you know, Monday at midnight, there's no guarantee that you're going to get your email. Do people read those emails? I will say they read them. Do they pay attention to them? Does that mean anything to them? All they know is they're not getting their email. And this will help you determine, are these people screaming reasonably? Like, holy cow, it's been 3 days. It should have, and for some reason it hasn't. You know, it's spotty across the world. So it's really kind of a cool tool. I wasn't familiar with it until John showed it to me, so I was happy to learn about that. So is that a performance test? It's more of a health check. But once again, that falls under our purview here. All right. TTL tweaks. When we're talking about TTL, we are talking about what? The length of time that a record should stay viable on a cached answer. So how do we figure out what those numbers are? Well, if you're the one who's responsible for that, you can just go to your DNS host and look what you put in. But let's say maybe you don't have access to that, you're helping somebody out, or that's another department that handles that, but you're dealing with the results of it, because well, that just never happens. All right, so command line tool built into all your computers there, NSLOOKUP. If we use NSLOOKUP with the -debug flag or option, and then put in what we're going to check here, I put in my company name, pulled it up, and gives me the answers I expect. But it's interesting. It says DTL 3973. So go try this on your computer. NSLOOKUP space -debug space and your domain of choice. Go get the result, and then click it again. And what you're going to find is that number is probably decreasing. And you're like, well, why is this changing? Well, what that's saying is the server that is answering this question has cached the answer, and every time you check, that time is counting down. But I'm trying to figure out what the actual defined TTL is, so this doesn't help me. It's interesting, but it doesn't help me. So the next thing I need to do is go in and figure out what the authoritative name servers are for that domain. Easy enough to do. Just do a whois lookup on it, using whatever tool it is that you would like to use. Typically, I just go into command line, just type in whois space and domain, and it will go whoop, and chances are that domain is like hidden and you can't see who owns it and all that kind of stuff. But the authoritative name server will be listed. So in this case, for my domain, it is ns1 and ns2.siteground.net. So now you all know who hosts my stuff. So I grab that information, and I click the up arrow, and I get that same nslookup space, debug space, domain name, space, and I plop in the authoritative name server. And it has to be the authoritative name server, because that's going to have the information about that domain. We talked about that before. Click the button. Now I can see my actual TTL is 14,400, which is kind of a standard TTL. So with no money, with nothing more than access to a terminal, I can examine the guts of my DNS records. Okay. What should we set our TTLs to? This is one of those situations where ask 10 people, 10 DNS administrators, their opinion on this. You'll probably get 11 different answers. But after looking at a lot of different resources, these are some standards that seem to be roughly agreed upon by the largest number of samples that I took. And you'll see that they're all different answers. We can change the TTLs for each of the types of records that we put in. If you recall doing it, that's a thing. I put it in. What should I put in here? I don't know. It's whatever default came up. Great, I'll take it. The reason why you might want to have different TTLs is the usage of those records. Some don't change that often. Probably a text record, once it gets put in there, will never change. You may remove it, but you're probably not changing it. Not a guarantee, because what's going to happen now is I'm going to go back to my room, I'll get a message, and it'll be something that I need to change a text record for somebody. But you can understand why you might want to have one thing, one another. And also, I did see something that made total sense. Let's say you are going to make that MX record change. Go change the TTL to that to like 5 minutes or something like that. Because that way, hopefully, the TTL will cause a faster propagation because the record's just not going to hang out as long. And then go back and change it again once you're pretty confident with those other tools that we showed you that the propagation has occurred. All right, any questions about that? Okay. So we just went through a bunch of testing tools. And because AI is absolutely the coolest thing on the face of the planet right now, and it's going to totally save us from having to do anything else for the rest of our careers, yes, I actually used some AI to generate some slides. And with a lot of modification, they actually were okay. So basically, you know, what are we going to use to determine? Well, we just went through that. We saw what tools that we had. I'm kind of wrapping things up here because I want to leave a little bit of time for questions. We need to know what tools we're going to use, but more importantly, what metrics are we going to use? What are we actually going to measure? We start laying out all those things. We see that we have tools that are pretty easy to obtain and pretty easy to use. Once we have the information, we can go into our optimizations, make some tweaks, whether it's TTL, simply making sure that we have the right records in the right places. We have determined what DNS servers we want our clients to use, which ones are testing good, which ones are testing not so good. Make those changes for them if we have the control. Caching. if you have the opportunity to put a caching server into a network you've got your users on, it makes a lot of sense to do that. It's really easy to do. It doesn't take a whole lot of setup. Who stopped in John's Proxmox presentation? So using something like Proxmox is a great way of providing the infrastructure to run DNS services on. And you've got some pretty good opportunities there. Tuning parameters, once again, going into the details, what can we tweak, what we can't tweak. And I was really hoping, honestly, when I first put this together and proposed this, that I was going to be able to give you a checklist of do this, do this, do this, and your DNS performance is going to be 10 times better. And I just realized I can't do that. But what I can do is give you the way of measuring the performance and seeing what makes sense in your situation. Because it's your network, it's your collection of tools that or services that your clients use, and it's going to be very specific to what you do, but the processes are going to be fairly universal. You know, what is it that we're going to try to get? What resources? What's the performance? How do we measure it? What do we have control over? And then make those changes. Okay, so I basically went through all this, but if we go about this in a logical manner, this will work each and every time, even though we may find out we're already pretty good. But that in itself is good information to have. Okay. If you have any questions, John and I's emails are here, or, well, we're all going to be leaving soon, but catch us in the hallway if you've got additional questions. And ultimately, at the end of the day, our AI user is much happier. And this picture is even weirder as you look through it. I'm still curious why there's two computers there, but at least these computers have keyboards, because the one in the other picture didn't actually have keyboards on it, or a keyboard. All right, so lastly, please give us feedback on this. And while I've been doing DNS presentations for a long time, this was a different approach on it, and I would love to hear what you have to say about it, so I appreciate your feedback. We have a few more minutes left. Questions? Sure you all got them. Or you're just like, this is the end of the week, come on, man.
One thing I was curious about, because you were showing how the tools...
Hold on.
Where are the danger bugs?
Danger!
One thing I was just curious about was when you're showing the different tools and how they can test the time, the milliseconds, returns, and stuff like that, and then the website that gave you like grades of C through A and such. From a baseline standpoint, how do I know what's a good return? Like, you know, let's say I run a tool, it says 50 milliseconds or something.
Right.
How do I know where that sits in the grading of good enough? Oh, I can actually improve this a lot, or only a little bit?
Okay, so great question. And if I break that down is, okay, I've got results. How do I parse those results? What can I do with those results? And good example, if you're within your own network and you do some sort of latency test, a ping or something like that, you would hope to get single-digit millisecond replies. And you can test from different areas on your network DNS resolutions and see what the numbers are. Over a period of time, you should be able to kind of see what the patterns are. And I can't give you, oh, if it's under this, you're good, but the lower the better. So if you're able to get internal resolutions, hopefully even in the single millisecond range or under 20 or something like that, you're probably doing okay. Depends on how complicated your network is and how many hops things have to take. But if you're in the outside world, I'm sure everybody's done this. You've got a computer plugged into your network versus one going wireless. As soon as you go wireless, your latencies skyrocket. And if you're dealing with a wirelessly connected device, you're going to have certain overhead that no matter how good the system is connected to it, that overhead is going to be fairly big. And you have to take that into account. So you still want to work on minimizing the other piece. But to answer your question a little bit more directly is, you're going to have to do a bunch of benchmarking and see what makes sense. You might go, all right, everything looks good here, and then you just call up a buddy of yours over at another location. Just do these tests. Tell me what you get. And you find out that their stuff is half of yours. Maybe you've got some work to do. Or maybe theirs is twice. And then you go, I think I can help you with this. So it's really a benchmark and respond to the benchmark. So, John, do you have any thought on that?
The only thought I have on it is that one of the things that some of those automated web-based things check for is not necessarily just the pure speed, but they'll make the same test X number of times and see what the variation is to see if the host that you're connecting to can reply consistently over time, or if it caches one but then falls behind. And that's also something that you might see with an internal caching server where it may be fine at some point, but once it's fully loaded, things fall off the end and you get some spikes in it, and then you could see that maybe you needed to upgrade or change that particular device. But I think what Ben said is appropriate about the timing. Obviously, if you see huge things, half a second or 500 plus milliseconds, it's clear that's probably going to be a problem. But seeing everything, 10, 50, whatever, it's a benchmark compared to what you need and what might be achievable on a different setup.
Cool. Other questions? Over here.
So, my question is about if we're running a local DNS server, how do we ensure that it's actually going to work and not be overridden by, say, like a browser that's decided that it's going to use a different DNS server than what the system is? As an example, I was trying to set this up for some testing, and my domain is a legitimate domain that I own. I got certificates for it so that I could do it, but I wanted to host something locally for testing, but it's 50-50 whether it goes to the hover parked page or that correct server, because some stuff I think pulls from a different DNS server just because the app decided or whatever. Is there any good way you can think of for troubleshooting that and trying to...
We have somebody...
What we did is we had something maybe similar like that where we used Squid, which was a proxy server.
Yep.
So we made them go through the proxy, which then forced them to get the cached data. In that specific instance, for like a workshop where we had large groups of people all doing the same thing. So that might be a possibility on a short-term type thing.
That's actually a really good way of doing it. Essentially, you end up having to force DNS resolution go where you want it to be. And how can you achieve that? You could achieve that on your firewall. You could say that only DNS requests, port 53 stuff is going to go to this DNS server, and we will block any other targets. That's pretty drastic, and I mean, it would be kind of, I don't even know why I do know why a browser, because browsers have gone so far beyond simply retrieving websites nowadays. They're like their own applications, trying to do their own application things, particularly like Chrome. It really wants to be its own OS. Oh, wait a second. So yeah, basically you're going to have to block requests that don't go where you want it to be. Or
and
use a
even
different browser.
that may not work all the time, because there's also DNS over HTTPS and DNS tunneled through various other protocols that is implemented in some browsers that even blocking the standard DNS ports
Good point.
or redirecting them, it still may go out somewhere else. So it may be impossible.
But at the same time, well, no, you wouldn't be able to see the inside the packets. Yeah, there's...
You can iterate through the browser settings, and force those off.
Yeah. Other questions? All right. Well, if there's no other questions, thank you so much for coming out. Really appreciate it. I hope you have a good rest of the show. There's one more session, and enjoy, and hope to see you all next year. Thank you.